Hello, my beautiful babes. So today is Thursday, August 27th, I believe. Yes. Um, so we are moving on to part two. We're going to start talking about physical and chemical reactions, or sometimes we call them physical and chemical changes. So the essential question and our learning target are the same, okay? Yesterday we did physical properties of elements. So we learned about metals, nonmetals, and metalloids, and you had an assignment. If you are still struggling with that assignment, let me know. Quick tip: if you count the energy levels, the circles, and then you count which would tell us our period number, and you count the valence electrons, which are in the outer energy level. That'll find your group. Remember, the number with an A next to it tells you. You'll find what element we're talking about. So that's just a quick tip. Again, if you need help, let me know. So moving on, physical and chemical changes. Okay, physical and chemical reactions. I say chemical reactions are basically a formation of a new substance. That is the best evidence that a chemical reaction has occurred, okay? Some examples you may know are frying an egg, okay? Or the leaves changing color in the fall, or wood burning. Another example that's a really good chemical reaction is like baking a cake. And we'll get into that in a minute. Physical reactions. The best evidence to let us know, to let you know that a physical reaction is taking place is it changes in shape or size, or it changes in state of matter. Remember, our states of matter are solid, liquid, and gas, okay? So if we have a log and we cut it into smaller pieces, it's still a log, it's just in smaller pieces now. That's a physical change. We have chocolate that's melting. We have a little Hershey's, okay? It's still chocolate though. It didn't change its chemical structure. It's still chocolate, so it's a physical change. And then crushing a metal can. If we get a can, or let's say we have a water bottle, okay? If I crush it, it's still a water bottle. I just changed its shape, okay? So let's get into physical changes. So over here, you will see, let me get my pointer. You will see here, somebody's cutting a piece of paper. So the piece of paper is being cut into smaller pieces. So that's changing its size and shape, okay? Over here, we have ice cubes. They're turning into a puddle of liquid because they're melting. That's a change of state of matter. So it went from a solid ice, to now it's going to be a liquid. That is a physical change. It is still ice. That paper is still paper. It's just a paper in smaller pieces, okay? So reversing physical changes. So when matter does undergo physical change, it does not become a different substance, okay? So physical changes, you can reverse them. That's the difference. Chemical changes or reactions, you cannot reverse them. You cannot. Physical changes, you can. So for example, when liquid water freezes to form ice, it can be changed back to liquid water by heating and melting the ice, okay? So even though our ice is melted, all we got to do, put it back in the freezer and it'll become solid again. Okay. Um, so salt dissolving in water is a physical change. How can this change be reversed? So let's say we have a glass of water. Okay. We put some salt into it and we want to basically get the salt in the water back. You're like, there's no way we can do this. It has to be a chemical change, right? Well, no. The salt water, you can boil it until the water evaporates and it'll leave the salt behind in the pan, okay? So the water vapor from the boiling water, it could be captured and cooled, and the water vapor would be condensed and changed back to liquid water. So it may seem like it's a chemical reaction because you're like, well, the salt has dissolved into the water. I can't separate the two, but you can. You just have to know how, which would, in this sense, would be boiling. Okay, boiling the water. So that's physical changes. Physical changes, it's you can reverse it. You can bring it back. It's the paper cut into smaller pieces is still paper. Can we reverse that? Yeah. We'd have to tape the little pieces back together, but it's still paper at the end of the day. We didn't change it into create a new substance. Okay. Now, chemical reactions, evidence of chemical reactions. There is a mnemonic device that we're going to use to help us remember chemical reaction. So if any of these take place, it is a chemical reaction. So we're going to call this, please excuse coughs, sneezes, and burps, okay? So whenever you cough, excuse me, whenever you sneeze, excuse me, well, you say bless you, but and then burps, we do say excuse me. So please excuse coughs, sneezes, and burps. That is this is similar to in math when we use PEMDAS, okay? Please excuse my dear Aunt Sally to remember. So this is the same thing. Please excuse coughs, sneezes, and burps. So the please is going to talk about a precipitate or a solid. Do not confuse this with precipitation, rain, okay? This is different. Precipitate is a solid. We'll get into that in a minute. Excuse is going to be an energy change or temperature change, okay? Or heat. Heat or coldness, okay? Coughs is going to be color. Just like our example of leaves changing color in the fall. That is a color change. Sneezes is going to be smell. Sometimes when we mix two substances together, they produce a smell. And burps is going to be bubbles or gas. So do not confuse bubbles, though, and gas with the gas from physical change, like change of matter, okay? Don't confuse the two. Usually, whenever you have a chemical reaction, you're actually going to see bubbles form, okay? And you'll see what I'm talking about in a moment. So please excuse coughs, sneezes, and burps. So first things first is precipitate or please. That's a solid. So whenever we mix two solutions together, a solid is formed. So this yellow right here, that is a solid that has settled at the bottom of the container. So they mix together these two chemicals, or these two solutions. When they mixed, the solid settled and became a precipitate. So if ever we do a lab and we do this and you see that there's a precipitate, a solid formed at the bottom, then you're going to be like, that's a chemical reaction, okay? So for energy, for temperature change, when two substances are mixed together, okay, and the temperature increases, that's a chemical reaction. It's releasing energy, okay? Or when two substances are mixed and the temperature decreases, that's a chemical reaction. It's absorbing energy, okay? So there are some instances when two substances are mixed together and the temperature will either increase or decrease. So if you have any kind of temperature change, it's going to be a chemical reaction, okay? Next one, color change. That's our coughs, okay? So we've done please excuse. Now we're at our coughs, color change. So notice the substances changing color. Those are chemical reactions. If we have like a penny or a nickel and you notice that some of them are rusted, rusting is a chemical reaction. It's changing the color, okay? This right here, they have a yellow substance. They mixed it with something else and it changed it to a pink substance. That's a chemical reaction. So color change is a chemical reaction. So we've talked about precipitate, solid, it settles at the bottom. We've talked about energy change, which is either we have some temperature increasing, so hot, or temperature decreasing, so cold. And then color change, rusting, or simply just changing from a yellow to a pink. Those are evidences of chemical reactions. So we have done please excuse coughs. Next is smell. So that is sneezes. So when substances are mixed together and it produces a smell, that's evidence of a chemical reaction, okay? So for example, we have here an egg. When eggs go bad, like really, really bad, and it's rotted, it produces sulfur, okay? It produces this sulfur. Sulfur has a terrible, that's whenever you hear, oh, something smells like a rotten egg. And that's sulfur, okay? That is a chemical reaction, okay? The next one is bubbles or gas. So when substances are mixed together and it produces a gas, that is evidence of a chemical reaction. So bubbling will often occur when a gas is produced. So sometimes when we mix substances together, it's going to create a gas. So for example, if I were to mix baking soda and vinegar together, it's going to create bubbles or a gas. That's a chemical reaction. Okay? That's usually what we use if, like, we did a science fair project and they wanted to create the lava in a volcano. You would just put in some baking soda and then you'd pour the vinegar and it'd create the bubbles, okay? So this is smell and this is burps. So we have gone through please excuse coughs, sneezes, and burps. We have precipitate, which is the solid that has settled at the bottom when two solutions are mixed together. We've done energy or temperature change, so temperature increasing or decreasing, getting hot or cold. And then we have done color change, so something resting or something when we mix two solutions together, they change color, okay? And then we've talked about smell. So for example, a rotting egg is going to produce a smell of sulfur. That's a chemical change. And then bubbles, okay? I gave the example of mixing baking soda and vinegar together to create bubbles or gas. So now that we have gone through our physical and chemical changes, you are going to, your assignment is this. You are going to do a physical and chemical changes virtual lab, okay? Use your notes. I provided notes. They say August 24th through 28th. What is a middle note? So the slides I just went through on my own, those are your notes that are in your chemistry notes in Google Classroom under Interactive Notebook, okay? Y'all, these notes are going to help you. I tried to simplify them the best I could and use visuals so it could help y'all, okay? Use them. They are a present from me. So what you're going to do is you're going to click this URL, okay? You are going to copy it and you are going to paste it into a new tab, okay? You are going to watch these mini videos, these stations, and you are going to tell me if it's a physical or chemical change based off your notes. Remember, physical is a state of matter. It's still paper, okay? It is still paper. Chemical, you can't, it changes its molecular makeup is what we call it, molecular makeup. So when I talked about baking a cake, think about the ingredients you put in a cake. We have eggs, we have flour, we have butter, we have sugar. And then you put it all together, you mix it up, you have a batter, you pour it into the cake pan, you bake it, and it comes out and it's this new thing. Now it's not just eggs and milk and butter and sugar and whatever else and flour you put into a cake. It created a new substance, okay? We can't go into that cake. We can't take out the eggs. We can't take out the milk. We can't take out the flour. We can't take out the butter or sugar. We can't do that. That's why baking a cake is chemistry. It is a chemical reaction, okay? So you are going to look at your please excuse coughs, sneezes, and burps. If you see any of those, it's chemical. If you see precipitate, energy change, color, smell, or bubbles being produced, it is a chemical reaction. Anything else, it's more than likely physical. So if the piece of paper, I cut it up, it's still a piece of paper. It just changed its shape. Ice melting. It is still ice. We can put it back in the fridge and it'll become ice again. That is a physical change. So you're going to go through the stations. They're like 20 to 30-second videos. You're going to put if it's physical or chemical. And I need to see the evidence. You need to tell me why you said it was physical or why you said it was chemical. Okay? And then we have questions for you to answer. You're making meaning questions. That's what's due today. So please get it done. And remember, today is the last day to get missing work turned in. If you need any help, let me know. And send me an email, or you can call me and we can schedule like a Google Meets or a Zoom. I have my Zoom the Zoom meet and stream for tutorials. I can use that as well, okay? So y'all have a wonderful day, and I will see y'all and talk to y'all later.